In space, Earth's atmosphere with its spiraling cloud masses is the face it shows to neighboring planets and stars. But on its surface, all life on Earth is subject to the atmosphere's ever-changing moods and expressions. On its seas, the whims of weather can sometimes spawn storms of such catastrophic proportions that their destructive potential is beyond the limits of human experience. That's what happened in October of 1991. Halloween weekend in New England turned suddenly into a hurricane-force nightmare. Huge waves bludgeoned the eastern seaboard as frantic mayday calls flooded rescue agencies. Desperate mariners caught up in the raging maelstrom, struggling to survive in the highest seas ever officially recorded. Rescue teams answered the calls of distress and found themselves fighting for their own survival. All were caught in the path of a killer storm, a rampaging giant cutting a lethal swath across 1,500 miles of ocean, headed straight for the coastal America.
The end of daylight savings time, so don't forget to set your clocks back an hour before bunking down tonight as we fall back for the season. Right now, partly cloudy skies, a pleasant 66 degrees at the airport. The high seas forecast, a gale warning from the National Hurricane Center. The area at this point well offshore to our north.
Shortly after midnight on Saturday, meteorologists at the National Hurricane Center began seeing the first stirrings of the various ingredients of the coming storm. Real-time satellite images and data buoy reports indicated the presence of a low-pressure system centered southwest of Bermuda. It fed off of the warm, moist air of the subtropical ocean, a process that, if continued, would culminate in the formation of a tropical storm and then a hurricane.
A hurricane is nature's true awesome power. A hurricane by itself could power the electrical needs of this country for 6 months if we could harness its energy. In the summertime, nature builds up this mass quantity of heat. She gets rid of that heat through processes such as thunderstorms, but much more efficiently through a hurricane, which is built on thunderstorms. Hundreds and thousands of convective elements, areas of rising motion in the atmosphere, produce thunderstorms which gather around a central point, an area of low pressure as we know it. It then begins to take on a life of its own, feeding off of the warm surface of the ocean, eventually to having that very noticeable clear center, the eye, around which all of its weather is rotating.
The eye of a hurricane, an area ranging 3 to 40 miles across, is one of Mother Nature's cruelest illusions. The air is still, skies are blue, all is quiet. The eye is merely the axle of a monstrous wheel. The most densely packed, fast-moving thunderstorms form the circular wall around the eye and the most violent portion of the storm, creating what's known as the stadium effect. By 10 a.m. Saturday, the subtropical low centered southwest of Bermuda had evolved into a tropical storm. The National Hurricane Center named it Grace. The storm continued to strengthen, and by 4 p.m. had developed wind speeds above 75 miles per hour, the point at which tropical storms qualify for hurricane status. So far, there was only one thing that appeared slightly out of the ordinary about Grace. She had developed north of the area where most Atlantic hurricanes are spawned, a swath of tropical waters stretching across the Atlantic known as Hurricane Alley.
Hurricane Alley is the area that starts out in the Atlantic between roughly 10-20 degrees north, east of the Lesser Antilles, going over to the Cape Verde Islands, and that is where some of the greatest all-time hurricanes have formed. The storms move west and then move into the Caribbean or the Bahamas and wreak havoc as they come. But once they approach 60 west, the tracks like to diverge quite a bit. Some of them will continue on west to west-northwest through the Caribbean and possibly even to Central America, the Gulf of Mexico, and the southern United States. Others will turn more towards the northwest and will hit the Bahamas, the Dominican Republic, Cuba, Florida, and the southeast U.S. Others will turn further north and miss the United States completely.
That is exactly what meteorologists were hoping for with Hurricane Grace, and every tracking and forecasting tool available was focused on her progress past Bermuda and along the eastern seaboard.
The GOES geostationary satellites provide us a moment-by-moment picture of how storms develop through the cloud imagery. We also have our latest computer technology in the form of our Doppler weather radar, which not only allows us to see those raindrops that are out there in those clouds, but also to estimate how much rain may be falling from the clouds.
Probably the single most important piece of information about a hurricane is its central pressure at sea level. The lower the pressure, the stronger the storm. To obtain this data, along with wind speed, direction, and other vital information, Air Force crews conduct daring low-altitude reconnaissance flights into every potentially dangerous tropical storm in the Atlantic. Flying rugged and highly adaptable aircraft, the so-called hurricane hunters transmit real-time information directly to the National Hurricane Center every 3 seconds. Surface-level data is also collected by whatever means possible.
We have ships out in the Atlantic. We have automated buoys and automated seaman stations, and just anybody else who has a wind gauge or a rain gauge or anything that can give us any information.
A network of volunteer ham operators even collects weather data from remote locations around the globe and forwards that information to the National Weather Service.
Or 27.55 inches.
These far-flung sets of eyes and ears tell meteorologists where a storm is located, where it's been, and where it may be going. Computer models are one of the tools they use to forecast what a storm will do next.
Some of them are quite simple statistical based. Others are very sophisticated, and the development of the supercomputer, which we use in Washington, D.C. for most of our weather forecasting, has been a tremendous boon to our science.
The primary object behind tracking and forecasting tropical storms is to provide adequate advance warning to people in vulnerable areas so that evacuation and/or other precautionary measures can be taken, as was the case on the Florida Keys before Hurricane George made landfall in 1998.
Everybody's ready. People are scared of this hurricane. People who haven't boarded up for 30 years, lifers here, are boarding up. Evidently it's coming, and everybody's getting prepared.
The bottom line is giving the public the best information we can to protect their life and property.
Getting people to act. That's what we view our job as. Not only are we forecasters, but we sometimes try to get in people's heads and try to make them respond correctly, even if our forecast may be wrong, and it is many times. So you have to allow for error and try to get people to act anyhow, and that's a tough one.
One of the most tragic examples of failure in this regard occurred on the Texas Gulf Coast on September 8, 1900. That day dawned on the seaside island community of Galveston with clear skies and sunshine. Crowds of people flocked to the beach to watch the unusually high surf that was smashing against the shore. The local Weather Bureau chief tried desperately to convince everyone that a powerful hurricane was fast on the heels of those high waves. Unfortunately, no one heeded his warning until it was too late. By morning, the formerly thriving city had been transformed into mounds of slime-choked debris, sandwiching the remains of the dead. More than 6,000 had been killed. Another 5,000 left homeless.
The 1900 Galveston hurricane is probably one of the, if not the greatest single natural disaster in our country's history. What happened was that as the storm came in, it brought a huge storm surge. Think of the tides as just being outrageously high, and it just overwhelmed the city of Galveston. So virtually all these people that died from drowning.
The phenomenon known as storm surge is responsible for more than 90% of the deaths caused by hurricanes.
A hurricane possesses three of the most deadly forces known to man: torrential rainfall, tremendous wind damage, not only on the coast but far inland, and devastating rises of our ocean levels called the storm surge, being hurled toward the coastline by those violent winds.
A storm surge is an artificial high tide, created in part by the storm's low atmospheric pressure, but compounded dramatically by the extreme winds driving the sea toward shore. As the storm makes landfall, this giant wall of water plows up shorelines, batters down structures, and inundates low-lying areas. In the last 70 years, the National Weather Service has greatly refined its forecasting techniques, as well as its close relationships with frontline life-saving organizations like the United States Coast Guard. One of the Coast Guard's primary responsibilities is to protect the lives of mariners at sea, and accurate weather forecasts play a vital role in the planning and execution of each and every rescue effort. During the Halloween storm of 1991, the U.S. Coast Guard would rescue some 75 people from various vessels in distress. Places like Air Station Cape Cod became beehives of activity, as the number and tempo of search and rescue operations, or SAR cases as they are called, rose with every passing hour.
Is 4010-07240.
Such rescues are commonly performed by helicopters with basket hoists and supported by other aircraft and Coast Guard cutters. Some rescue cases require the highly specialized skills of a rescue swimmer, emergency medical technicians known in the Coast Guard as aviation survivalmen.
We realized that we weren't going to always be able to just hoist a basket down in the water and have someone swim over and get into it. There was times where hypothermic people were in the water and weren't able to get to the basket. So that's when the Coast Guard realized we're going to have some other way of doing this, and that's when the Coast Guard swimmer program came about.
As these men would be expected to enter the most treacherous conditions imaginable and stay there until a rescue is completed, only candidates who surpass the very limits of physical and mental endurance graduate from the Aviation Survivalman program.
Yes, it's a physical thing, but the psychological part is they're trying to get you to stop. And when we're out in a SAR case and we're in the water for 30, 40, 50 minutes, they don't want you to just quit.
Anybody that wants to be a rescue swimmer, man or woman, I think has a fundamental desire to save lives. They're very gung-ho, and it takes a certain breed of humanitarian to want to do that, to jump into harm's way, to deploy into waters unknown to rescue somebody that you have no idea who they are. It takes a certain esprit de corps.
Carolina coast will be under a flood watch Monday and Tuesday, with more bad weather to come. The small craft advisory predicts 6 to 8 foot seas in advance of Hurricane Grace.
By late Sunday, Hurricane Grace was just one piece of a complex and menacing puzzle that was developing over the Atlantic. From the satellite images they were receiving, meteorologists believed they were witnessing the formation of a singular and extremely dangerous storm. A storm unique for not only its size and devastating intensity, but for the very misleading conditions preceding.
We knew that we had a very, very dangerous system out there for the mariners. But as this system began to unfold, it became even more difficult to get that message to the public because the sensible weather over New England was sunny. The sun was out. We had a chilly but very typical holiday weekend in New England. So we had sunshine, yet this monster producing deadly waves and seas just offshore.
Although the forecasters lacked sufficient information to predict just how severe the storm would become, the warnings went out.
Torrential rains of 1 to 2 inches are possible in less than 1 hour.
Though no weather forecaster wanted to be accused of crying wolf, none of them wanted Halloween 1991, like Galveston in 1900, to be remembered in the years to come as a byword for disaster.
That
That rise in barometric pressure and drop in temperature we're experiencing is courtesy of that Canadian cold front passing through New England. But the National Weather Service tells us several other things are complicating the weather picture here in the last week of October, particularly on the coast.
Besides Hurricane Grace, there were two other key players in the drama unfolding in the Atlantic. Each one had been under careful scrutiny by the National Weather Service since late in the previous week. The first was a high-pressure system marked by a strong cold front, pushing its way southeastward from Quebec across New England and the East Coast, as far south as North Carolina, where Hurricane Grace was about to collide with it.
On the weekend just prior to this big event, it was a fairly nice weekend here in New England, and with little sense of an impending dangerous storm out in the west central Atlantic. I do recall on Sunday evening kind of watching television and noticing the strength of high pressure building in southeastern Canada on one of the TV stations, but that's all I knew prior to walking into the office on Monday morning.
By odd coincidence, as they approached the point of impact, the Canadian cold front and Hurricane Grace were simultaneously reaching their peak intensity. At the same time, a low-pressure system was skating out ahead of the cold front, gaining strength as it moved into an area just off the coast of Nova Scotia, in the vicinity of a tiny wind-swept piece of land called Sable Island. According to the best computer models developed from nearly a century of statistical weather data, the National Weather Service was predicting that Grace would collide with the high-pressure cold front, then continue on a northeast heading, following the low into the mid-Atlantic. But something went wrong. The low stalled at Sable Island. Energized by the warm, moist air of Hurricane Grace to the southeast and the cold, dry air of the Canadian cold front to the west, the Sable Island low would begin an explosive feeding frenzy, ballooning to such